Okay, so let's start chapter 3, part 2. Okay, about equilibrium now. So last time, ano yung na-cover natin? We were able to cover the equilibrium concept. So according to equilibrium concept, it is a state of your system wherein the rates of the forward and reverse reaction is equal na. So ibig sabihin, yung reactants na pupunta sa products, pero yung products bumabalik din sa reactants at the same time. Okay? So yan. So that is a state of system wherein two reactions are happening at once, forward and reverse reactions. Equilibrium systems are always described by equilibrium constant. So equilibrium constant is a description of the ratio of the amounts of the products over the reactants of your system. Okay. So yan. So we can write the equilibrium constant with this format. Okay, so that is the concentration of products raised to their coefficients divided by the concentration of the reactants raised to their corresponding coefficients. So the concentration can either be expressed in molarity or in pressure units in atmospheres. No? So if your equilibrium constant is expressed in molarity units, then you have Kc. If your equilibrium constant is expressed in atmosphere, then you have Kp. Okay. For aqueous species, you only have the Kc. No, because you cannot express aqueous species into gaseous forms. No? So for aqueous systems, you only have Kc. However, if you have gaseous phases, you have both Kc and Kp, as gases can be described with molarity or with pressure units. Okay, and then uh, we also reviewed the relationship of Kp and Kc. Okay, suppose you're given Kc, you are asked for Kp, then you can use this equation. Okay, so that's Kp equals Kc parenthesis RT raised to delta N gas. No? So R is the gas constant, 0.08206. T is the temperature in Kelvin, and delta N gas is the moles. That is the difference of the moles of the product, moles of gas in the product, and the moles of gas in the reactant. So that's delta N gas. Then yan, nagsagot-sagot tayo ng basic equilibrium problems. And then we also covered the operations with equilibrium constants. So depending on how you write the equation, your equilibrium constant may change. No? So suppose you flip the reaction. So flipping the reaction would cause the equilibrium constant to be reciprocated. Okay, so kapag binaliktad yung equation, the equilibrium constant reciprocates, no? So bumabaliktad din siya, numerator, denominator, nagfi-flip. Okay? So yun. So depending on how the equation is balanced, k can be affected as well. Suppose you multiply the equation by 2, then your k will be squared. If you multiply the equation by 3, your k will be cubed. If you divide the equation by 2, you get the square root of your k. And then if you divide the equation by 3, you get the cube root of your k. Okay? So depending on how you balance the equation, may corresponding change yan sa k natin. Okay? And also, when you combine equations, we multiply the equilibrium constants. No? I-multiply mo lang sila. So, yan. Okay, so ano yung pinakakailangan natin i-take note that when writing equilibrium constant, only those in aqueous phase and the gaseous phase are to be written. No? So, hindi mo pwede isulat yung solid and liquid. Bakit? Next week, i-discuss natin yan. Okay? So, yan. We also covered the prediction of the direction of reaction. So, we can tell where the reaction is going with the insight on the initial amounts of your species, no, before achieving equilibrium. Okay, so we can do that by comparing Q and K. No? So Q is the reaction quotient, K is the equilibrium constant. What's the difference? No? For K, that is the equilibrium constant at equilibrium. Okay, so ibig sabihin yan, balance na yung system. Yan yung dapat na value niya. But Q rather, but Q is the initial ratio of your amounts, no? So siya yung before ma-reach yung equilibrium. So depending on the ano, depending on the difference of Q and K, you can tell where the reaction is going. So if your Q is less than K, yung Q yung orange, yung K yung blue. So if your Q is less than K, then in order to achieve equilibrium, your reaction must proceed to the right, no? If your Q is equal to K, then you are already in equilibrium. But if your Q is greater than K, in order to achieve equilibrium, the system has to go back. Okay? So to the left yung kanyang shift. Okay? And then, yun, nag-solve tayo. Okay? So, ang sinolve natin dito, we started with the initial amounts. So, we started with the initial amount, then we just tell kung saan pupunta yung reaction. For our session today, kadugtong to ng previous topic. Okay? So, our topic for today is paano natin kukunin yung equilibrium concentration, no? Kasi last time, alam natin saan yung reaction papunta, to the left, to the right. Okay? Then, ang tanong dito sa mga susunod na question natin, ano na yung equilibrium concentration? So, you are given the initial amounts, then you will be asked how much will, I mean, nawala yung word. Okay. So, ang given ay initial concentration tapos pagdating sa dulo ng problem, ang tatanungin how much yung dami ng chemical species mo at equilibrium. Okay? So, parang ganito lang. Okay, so suppose meron tayong ganyan. We have 0.850 molar of the cis isomer initially. Ang itatanong sa atin, yung equilibrium concentration. So, paano yon? Ang alam pa lang natin sa ngayon ay yung pag-predict ng reaction, kung saan siya papunta. Pero, paano natin isosolve ito? Madali lang, okay? Sa tulong ng algebra. So, in order to answer problems like that, wherein given yung initial concentration, hinahanap ay equilibrium concentration, we have to make use of the ice table. So, some references will call it rice table. Okay? So itong ice and rice table, they are just the same now. So this table will allow us to see what are the changes in the amounts of our species as they try to achieve equilibrium, no? So gaano nagbabago yung mga chemical species natin, by how much sila nagbabago as they try to achieve the balance or as they try to achieve the equilibrium. So itong ice table, that is an abbreviation. So yung R, yun yung reaction. Yung I, that's the initial amounts. The C is the changes in concentration. And E is the equilibrium amounts. Okay, the equilibrium concentration. Okay, so to answer such problem, una mong gagawin is to construct ice table. So susulat mo yung ice table lang. So, susulat mo yung equation sa taas. Tapos sa gilid, lalagay mo I, C, and E. Mamaya pakita ko kung paano yun. Then, next is, dun sa given problem mo, hanapin mo yung initial concentrations. Okay? Then yung C, paano mo i-fill out yon? How about the change? So, for the change, it could either be positive or negative, no? Pwedeng madagdagan yung product, pwedeng mabawasan din yung product, depending on the direction of the reaction. So for you to answer C, important na alam mo yung direction ng reaction. Okay? So kailangan alam natin saan papunta yung reaction, to the left, to the right. No? Kapag to the right yan, the change is positive for the product side. Ibig sabihin, dadami yung products as they try to achieve equilibrium. Okay? And for the reactant, that will be negative change. If ang reaction naman ay going to if ang reaction mo naman ay going to going to the left, then ang change for the reactant is positive. And the change for reactant is, the change for product is negative. Okay? So, depende kung saan pupunta yung reaction, pwedeng positive or negative yung change natin. Okay? By how much they will change, I don't know. Diba? So, lalagay natin yung variable x. So, dito natin makikita sa C that our chemical species, yung concentration nila, they change by X, no? We do not know yet the value of X, eh. Tapos after nun, we solve for the value of X, and then once X is determined, we can calculate for the equilibrium concentration na. Okay? So, parang abstract pa lang yung idea ngayon, no? So, ano sabi ko una, gawa ka ice table. Pangalawa, ilista mo yung initial amounts. Pangatlo, alamin mo yung changes, no? Using the help of Q and K. After nun, you solve for the value of X na. Okay? So, let's try, no? Madali lang to, don't worry. So, let's have this problem. Isomers of steel bean have an equilibrium constant Kc equals 24 at 200 degrees Celsius. The reaction is given. Suppose initially there is 0.85 molar cis isomer. Calculate the equilibrium concentration of all species or of all substances. Okay? So, una, ang sabi ko sa inyo, ang format ng question dito ay ito. Ibibigay sa inyo yung initial amount. Tapos hahanapin equilibrium amounts. Okay? So kapag ganun yung nakita nyo sa problem, given initial, hinahanap equilibrium, gagamitin nyo yung ice table. Okay? So ano yung first na gagawin mo? Gumawa ka ng ice table. Okay? So in order for us to construct the ice table, you write the equation first on the top. Okay? Shortcut ko na lang yung cis steel bean, pati trans steel bean as cis and trans. Okay? So, yan yung R, yan yung reaction mo. Followed by I, C, and the E. Okay? So, on the left, ayusin ko lang. Wait lang ha. Ayusin lang natin para pantay. So, yung reaction, sulat mo sa taas, cis, then trans. Okay? So, yun nasa right, yun yung product. Yun nasa left, yun yung reactant. So, I, as I told you, initial amounts yan. Okay? So, tingin natin yung problem. Basahin natin yung problem uli. Ano yung initial amount ng ating species? No? So, sabi, sa second sentence, suppose initially there is 0.85 molar cis isomer. So, ibig sabihin nun, 0.85 molar ang cis isomer natin. So, susulat ko lang 0.85. No? Hindi ko nalalagay yung unit. Understood na? Molarity na yan. How about the trans? No? Alam na ba natin yung trans, yung dami niya? Hindi, no? Kasi walang sinabi sa problem. Pag walang sinabi sa problem, 0 yon. Okay? So again, kapag walang sinabing amount sa problem, automatic, 0 yon. So wala tayong amounts ng trans, only the cis lang. What's next? Yan na yun. Yan na yung I. Initial amounts. Kapag walang sinabi, 0 yon, matic. Okay? How about C? Change. So, sabi ko sa inyo kanina, the change could either be positive or negative for the reactants or products depending on the direction of the reaction. So that means we have to use QC and we compare that to the K. Okay? So let's compare Q and K. So K is already 24, given na yan. How about Q? Okay, so for Q, the equation can be written as the concentration of trans initially over the concentration of cis initially. Use your ice table para alam mo yung susulat mo dyan. So your trans is 0 molar. Your cis is 0.85 molar. What's 0 divided by 0.85? 0 yan. So that means if you create a number line, k is equal to 24, asan yung q? Nasa left. Q is equal to 0. In order for the system to achieve equilibrium, it has to shift towards the right side. Kailangan niya ma-push towards the right side, no? Para ma-achieve yung equilibrium. So, yun yung direction ng reaction. Ang question is, paano ko siya ita-translate sa ice table? Alam natin yung reaction papunta sa right. Paano ko isusulat yun sa ice table? Madali lang. Since the reaction is going to the right, dadami yung products mo. So that means the change for the product is positive. And the change for reactant will be negative. Mababawasan yung reactant kasi dadami yung product as it shifts to the right. Okay? So papunta sa right yung reaction. So ibig sabihin nun, dadami yung product, mababawasan ang reactant. By how much? I don't know. So lagay tayo ng variable x. Okay? So cis will change by negative x. Mababawasan siya by x. Yung trans madadagdagan by x din. Okay? So ganun po isulat yung nasa C. Sa row ng C. Again, paano? Paano yung change? You determine where the reaction is going. Okay? So alamin mo, saan papunta yung reaction? To the left, to the right. No? On our particular case, to the right. So ibig sabihin nun, positive X for the products, negative X for the reactant. Okay? So ganun lang. Shortcut. Ito, shortcut. Para hindi nyo nagawin yung Q. Ano yon? Kung nasan yung 0, dun pupunta yung reaction. Okay? So, tignan nyo, kung nasa reactant ba yung 0 na initial concentration or nasa product. Kung nasan yung 0 concentration, dun pupunta yung reaction. Okay? Because kapag may 0 ka dun, your Q will always be less than the K. Or, pwedeng greater than K. Okay? Kunwari, sir, what if baliktad yan, no? 0.85 sa taas, 0 sa baba. Ano yung, what's 0.85 divided by 0? Undefined, no? Okay, so undefined yan. So kapag undefined, nasa right side yon. Okay, andito yung undefined. Okay, so yan. Minsan infinity pa nga yan, no? So kapag ganun yung number mo, undefined or infinity, nasa right side yung Q mo. So in order to establish equilibrium, it has to go to the left side. Nasaan yung mouse pointer? Ito. So, yan. Kapag ang quotient mo ay divided by 0, undefined yon. Okay, so nasa right side yung Q mo. Kapag 0 yung Q mo, nasa left. Okay? Yan. Yan lang. So again, kung nasan yung 0, doon pupunta yung reaction. For example, ito, nasa product yung 0, that means the reaction is going to the product. Okay? So, yun yung shortcut ko. Hindi ko na ginagawa to actually. Mental na lang. No? What if, sir? Sir, what if may numbers yan? Di gamitin mo yung reaction quotient. No? Wala na akong shortcut na magagawa doon. Gamitin mo na talaga yung Q. Okay? Kunwari ito, 0.1 molar. Di solve mo na yung Q. Okay? Para mas clear. So, yan. So, that's how we construct the ice table. I, initial amount, stated yun sa problem. Pag hindi sinabi, 0. C, change. Paano mo malalaman yung change? Determine where the reaction is going. For E, that is the equilibrium amounts. To determine the equilibrium amount, that is just I plus the C. Pagsamahin mo lang yung I pati yung C. Okay? So as it achieves equilibrium, cis will now be 0.85 minus X concentration, and as trans achieves equilibrium, ang kanyang equilibrium concentration ay X. Okay? So again, for the E row, for the row ng equilibrium, you just add the I and the C. Pagsamahin mo lang yung I pati C. Okay? Ano susunod? So since you now have the equilibrium expressions, ipa-plug in mo yon sa equilibrium constant. Okay? So let's write the equilibrium constant. K is equal to trans divided by the cis. Okay? So, saan ko nakuha yung equilibrium constant? Dito sa equation. Okay? Tapos, anong gagawin ko? Plug in mo yung given. Ano yung mga given natin? Kc is given. Yung equilibrium expressions for cis and trans, given na rin. So, ito, pa-plug in ko dito. Ito, plug in ko dito. Ito, plug in ko doon. So, lahat yan ipa-plug in natin sa K. Okay? So, let's write K is equal to 24. Ano yung concentration ng trans at equilibrium? X. Ano yung concentration ng cis at equilibrium? 0.85 minus X. Once you were able to substitute all the info from the ice table and the K value, once na masubstitute mo na yan, your next task is to solve for the value of X. Okay? So may calculator shortcut dito. Nasa video na yung link nilagay ko sa message ko dito sa chat box natin. Okay? So andyan yung link sa chat box. Pwede nyo i-shortcut na to. Pero for the purpose of our discussion, manual ko i-solve. Okay? Para masundan. So let's solve for the value of X. Anong gagawin mo? Cross multiplication. So itong nasa denominator, cross multiply mo sa 24. Okay? Pagpalitin ko lang sila ng pwesto. Okay? Pinag-switch ko lang ng pwesto. Dapat kasi andito ito sa left side. Kaso, susobra ako dito eh. Ganyan na lang. So that will be x equals 24.85 minus x. What's next? Algebra na to, wala ng chemistry dito. So algebra tayo. So what's next is you distribute this term to the contents of your parentheses to your binomial. So distribute mo ito dito pati doon. Gawin natin yan. 20.4 times 0.85. So that will be 20.4. Okay, so 24 times 0.85 is 24. Okay, and then you distribute 24 sa x. That will be negative 24x. Ano susunod? Yung negative 24x, ilipat sa x. No? So magiging positive yun. So we will have 24x plus x equals 20.4. What's 24x plus x? 25. No? So we write 25x equals to 20.4. So we solve for the value of x by dividing both sides of the equation by 25. Okay, so x value would be 0.816 molar. Okay, so yan yung, yan yung value ng x, 0.816. Okay, so yan eh, nasolve na natin yung x, but we're not yet done. Okay, daming ginawa, hindi pa tayo tapos. Kasi ang hinahanap, equilibrium concentration, hindi yung value ng x. So to solve for the equilibrium concentration, we have to go back to our ice table. We already know the value of x, 0.816 yon. Ipa-plug in natin yon sa ice table. Okay? Para masagutan yung problem. So that means, to solve for the cis concentration, that will be 0.85 minus 0.816. For the trans, that will just be 0.816 molar. Okay? So, isolve na natin yung kanilang true equilibrium concentrations. Okay? So, for the cis, ang kanyang equilibrium concentration na ay 0.34 molar. So, yan na yung concentration niya at equilibrium. How about the trans isomer? Di yun na yun. Wala na tayong gagawin. 0.816 molar. Okay, so that's how we solve for problems like this. No? Let me highlight it na lang yan. Okay, So again, paano natin sinagutan tong problem na to? Okay, so anyway, so paano uli natin sinagutan tong problem na to? First, we write the ice table. So dun sa ice table, we substitute the values, the given concentrations, no? So kunwari sabi sa problem, 0.85 cis, edi lagay mo 0.85 for the cis. Walang sinabi about the trans, so 0 yon pag ganun. So for C, the change, alamin nyo where the reaction is going. You can use Q o kaya yung shortcut na sinabi ko. Sabi ko, kung nasan yung 0, doon yung reaction. Doon siya pupunta. Okay? So since 0 tayo sa trans, doon pupunta yung reaction sa product side. So paano natin ita-translate yun dito sa C? Pag to the right yung reaction, positive yung change for the product, negative yung change for the reactant. Okay? Another thing, no? What if may coefficient dito? Kunwari, 2 cis equals 2 cis in equilibrium with 3 trans, no? Ano gagawin ko dun sa coefficients? So, yung coefficient mo, i-multiply mo yon sa x. Okay? So, kunwari ito, 2 cis, edi lagay mo, negative 2x. Kunwari ito, 3 trans, ilagay mo, positive 3x. Okay? Why do we have to involve yung stoichiometric coefficient, no? Kasi we still follow the conservation of mass, okay? We follow the law of conservation of mass. That means they must be related stoichiometrically. Yung changes, affected yun by the stoichiometric coefficient. So again, kapag may coefficient to, ilalagay mo rin yun sa x. No? Kaya ito, 2. Ilagay mo, negative 2x. Kaya ito, 1 half. Ilagay mo, positive 1 half x. Okay? So, ganun. So, yan. Ayan. Ganun lang. Pero dito kasi 1:1 lang yan. Kaya x lang nilagay natin. Then, for E, anong gagawin mo? You just add I and the C. Then, after mo makuha yung E, ipa-plug in mo yon sa K. Now, you write the K, plug in mo yung E ng cis, yung E ng trans, pati yung K value. So, pagdating mo dyan, stop ka na sa chemistry, algebra ka na. So, solve for the value of x. Once na nakuha mo na yung value ng x, balik ka sa ice table. Okay? To get the actual equilibrium concentration, you have to plug in the value of x. So, that's 0.85 minus x. Yan ay 0.85 minus 0.816 na because the value of x is 0.816. So we get that at equilibrium, the cis isomer is 0.034 molar. So the trans isomer is just x, so yun na yun, 0.816 molar na siya. Okay? So ganun lang siya kadali. In order for you to check, no, you divide the product over the reactant. Try nyo kunin yung K value if you divide this by this, no? 24 yan. Okay, so try mo i-plug in. 0.816 dito, 0.034 sa baba, equal yan sa 24. So, ganun yung checking lang dito. You plug in your equilibrium concentrations and it must give you the equilibrium constant. Kapag hindi equilibrium constant yung lumabas dyan, may mali. Okay? So, either nagkamali ka sa solving ng x, no? Or nagkamali ka dito sa change, no? Doon lang naman kasi mga sources ng error. Okay? Kasi ayan, easy pa lang, di ba? Hirapan natin. Okay? Alam nyo naman, pag may numbers, mas masaya, di ba? Okay, so let's try the second problem. A mixture of 0.75 mole of hydrogen gas and 0.75 mole of iodine gas was placed in a 1-liter stainless steel flask at 430 degrees Celsius. The equilibrium constant for the reaction given below is 54.3 at this temperature. Calculate the concentrations of H2, I2, and HI at equilibrium. Again, we are given the initial amounts of our substances, and we are asked to solve for the equilibrium concentration. Kapag ganun yung format ng question, we have to use ice table. Okay? So, gawa kayo agad ng ice table. You write the reaction uli. Ay, ba't kulay green? Kulay black naman. Blue. Ayan. Okay. So, lagay mo yung reaction uli. H2 gas, I2 gas, in equilibrium with 2HI. Then, you write ice, no? Ice lang. Okay, so yan. So, yan na yung ating ice table. Yung HI yung product, yung H2 and I2 yun yung reactant. Okay, balik tayo sa problem. Ano yung initial concentration ng ating species? Basahin natin yung first sentence. Andun kasi yung sagot. So sabi dyan, a mixture of 0.75 mole of H2 and 0.75 mole of I2 was placed in a 1 liter stainless steel flask. Ano yung lalagay mo dyan? Sir, sabi doon yung mole. Edi yung mole ilalagay ko. Hindi. No, hindi pwede yon. Bakit? Kasi sabi ko, when dealing with equilibrium expressions, only molarity and pressure are allowed. Okay? Kunwari, grams yung binigay dyan, i-convert mo yan sa moles or sa pressure just by using molarity equation or the ideal gas equation, PBNRT. Okay? So, kunwari, grams binigay dyan, i-convert mo pa yon to either pressure or the moles depending on the situation sa problem. Okay? So, yung binigay sa atin, mole, ano kailangan natin? Yung molarity. Bakit molarity? Kasi Kc meron tayo eh. Okay? So, molarity yan. So, what if Kp yan, sir? Kunwari, Kp yung given. E di yung mole, i-convert mo to pressure. Okay? So, ganun gagawin nyo. Paano kayo i-convert yung mole into pressure? Ideal gas equation. P is equals to nRT over V. Okay? So, yan. Ganun lang, ha? Again, be careful. May ganyan ba sa quiz? Hindi natin sure. No? Although naglagay ako on 10. No? Alam niyo naman, mas malaki yung points pag ganong question. Naka lang. Tsaka 2 attempts naman, kaya nyo yun. Okay. So, napansin ko ginagawa ng ibang students dun sa chapter 3 nila sa laboratory. Sasagutan nila, yung first attempt, mas mababa score nila syempre. Tapos, sinasagutan nila daw yun uli. No? So, pagdating nila ng retake, yun uli yung questions. Yun. Nalagay na nila yung tamang answer nila. Mababa pa rin score. The joke lang. Hindi, tumaas naman. Okay. So, yan. Ano gagawin natin? Yung mole, hindi yan yung ilalagay dito. Kasi case ito, molarity dapat. So, paano mo kukunin yung molarity? You divide the moles by the volume of your solution. Or in our case, volume ng container kasi gases to. So, you divide mole by the volume. So, that will be 0.75 mole divided by 1 liter equal yan sa 0.75 molar. So, lagay natin dito, 0.75 molar. Ganun din si I2. 0.75 mole divided by 1 liter, edi 0.75 molar din. How about HI? May sinabi ba sa problem? Wala. Wala siyang sinabi about HI. So, ibig sabihin nun yan ay 0. Okay? Again, kapag walang sinabi, 0. Yan na yan. Okay, so this is our ice table. 0.75 molar, 0.75 molar, 0. Okay? How about the change? No? As I told you earlier, kung nasaan ang 0, dun pupunta yung reaction. We have the 0 sa product side. Okay? So that means the reaction is going to the product side. Paano natin isusulat yun sa C? Since the reaction is going to the product side, your reactants will decrease. So the change is negative. Okay? So we write negative X for H2 and negative X for the I2. Kasi mababawasan sila. Sino yung madadagdagan? Ito yung product kasi dun nga papunta yung reaction, di ba? So we will write positive 2x for the product. Sir, bakit positive 2x? Hindi ba positive x lang? Okay, sabi ko kanina, kapag may coefficient, you multiply it sa x. Okay, so we have 2 here. So gagawin mo siyang 2x. What if 3 po yan, sir? Edi 3x. What if 5 yan? Edi 5x. Okay? So again, you multiply your coefficients to x. Okay? Whenever you are doing this 0 here. Okay? Kunwari, ito may 2. And ilagay mo 2x. Okay? So, ganun. So, yan. Yan na yung C. How about E? Equilibrium. So, again, for E, you just add I and C. Ipag-add mo lang yung dalawa. 0.75 minus x. Edi 0.75 minus x yan. Ito rin, 0.75 minus x. On the product side, ano sagot? 0 plus 2x, edi 2x lang. Okay? So, yun na yun. So, we're done with the ice table. Now, ipa-plug in natin yan sa K. Okay? So, let's write the equilibrium constant here. Sana kasya pa yung space. So, what's the equilibrium constant for our equation? So, that will be, ito, magalaw yung screen. Okay, so the equilibrium constant for this given equation here can be written as the concentration of HI squared divided by the concentration of H2 times the concentration of I2. Okay, sulat mo muna yung equilibrium constant expression. Then, you plug in whatever is given sa ice table. Okay, so ano yung value ng K? Ano ba sabi sa problem? 54.3 daw yung K. So, I will plug in 54.3. Numerator. What's the concentration of HI at equilibrium? Tingin sa ice table. Ano yung equilibrium concentration ng HI? 2x. Okay, so ipa-plug in ko yung 2x doon. So, that will be 2x, then square. Okay. How about H2 and I2? Okay. So for H2, tignan natin yung H2. 0.75 minus x. For I2, 0.75 minus x then. Okay. 0.75 minus x. 0.75 minus x. After nyan, algebra na. Okay? Sa algebra na tayo. Alam ko, favorite nyo yan. Ano gagawin nyo sa denominator? You have a product of binomial. So, yan ay FOIL method. Okay? FOIL method. First terms, outer terms, inner term, and then last term. Okay? Di ba nakaka-enjoy kasi may algebra? Okay? So, ganun lang. So, FOIL method natin yan. Okay? Lang. So, i-FOIL method natin yan. Ito. First terms. 0.75 times 0.75. Calculate nyo na yan. So, that's equal to 5625. Okay? Sulat natin ulit. 54.3. O, yung numerator pala muna. What is parenthesis 2x raised to 2? So, mangyari dyan, yung 2 may square, yung x may square din. Okay, so we will have 4x square on the numerator. Baka isipin nyo, 2x square ha, mali yun. Okay, mali yun. 4x square yan, pag ganyan. Okay. First terms, 0.75 times 0.75, that will be 0.05625. Okay. First, outer terms, nasa O na tayo ng FOIL. This times negative x. Okay, so that will be negative 0.75x. Inner terms, negative x times 0.75. So negative 0.75 uli yan. Then last term, negative x times negative x, positive x square. Diba? Saya mag-algebra. So, anong gagawin? Simplify mo yung denominator. Pagsamahin natin yung parehas na negative x. So, that can be written as 54.3 equals 4x squared divided by 0. Ito na naman ako sa typo ko. Teka lang ha. Wala yung 0 pala dito ha. Sorry. Maski kamay na to typo. 0.5625 lang pala yan. 5625. Yung negative 0.75x minus 0.75x, that will be negative 1.5x plus x square. Yung ganitong question, siguro sagutan nyo na lang to ulit after the session kasi limited yung class hours natin sa lecture 2 hours lang Kaya bitin talaga tayo parate, no? Kaya parang nagmamadali tayo kasi 2 hours lang tayo so, ayun. Kailangan natin talaga siya madaliin, no? Okay? So, kaya nga recorded to para pag magre-review kayo, pwede nyo sagutan na lang ulit, no? So, ganun. So, pwede nyo i-derive ulit to after the session. Okay. So, yan. Napagsama na natin yung dalawang negative x. Then, ang susunod, cross-multiply. Okay, so, I will cross-multiply this denominator to the other side. So, that will give me 4x squared equals 54.3 times 0.5625 minus 1.5x plus x squared. Okay, so cross-multiply ko lang, I got this number. Anong gagawin? Distribute 54.3 sa contents ng parenthesis. Okay, i-distribute this sa individual terms. Teka lang, copy ko lang ha. Wala na akong space Hindi ako naka-out OneNote. Sir, kailangan ba namin gawin tong ganyan? Kasi 45 minutes lang binigay nyo sa amin sa quiz Ganito, sagot. Pag nakita nyo yung calculator shortcut, kaya nyo to sagutan very quickly. No? So, kailangan mo lang gawin ay ito. Pag nagawa mo na yan, i-ano mo na lang yan, calculator method. Pwede rin naman, hindi ko naman pinipigilan kayo, no? Alam nyo yung Symbol Lab. Okay, yung Symbol Lab, that is a website wherein siya na yung mag-algebra for you. Ako ginagawa ko yun Okay lang naman sa akin. Kasi syempre time consuming din, di ba? Pwede nyo gawin yun. Symbol Lab ang website. Huwag yung Wolfram Alpha. Kasi pag nag-Wolfram Alpha kayo, kung ano-ano lalabas dun Okay. So, okay na yung Symbol Lab. Don't worry, ginagamit ko rin yun. Kaya okay lang din. Kung ako ginagamit ko yun, dapat kayo din, di ba? Para mabilis yung calculation. Although, it will still be better if you can solve it manually. Okay. Kasi mamaya, tanungin kayo sa kanto, iho, iha, square mo to, di ba? Tapos di mo nasagutan, di ba? So, yan. Mas maganda yung alam nyo pa rin siya gawin manually. Okay? Bago kayo mag-shortcuts. Okay, so yan, you distribute the term. 54.3, multiply ko yan, 54.3 times 0.5625. Daming numbers. 30, 54375, 54375. Okay. Yung 1.5. So, 54.3 times negative 1.5. That will be negative 8145. And then lastly, we have 54.3x squared. Ano susunod mong gagawin pag nakuha mo na yan? Next thing is i-format mo yung equation into this. Sulat ko yung format ng equation. You have to write it in this manner. Ax squared plus bx plus c equal 0. O yung 0 pwede nasa right, pwede nasa left. No? Basta ganyan yung format. X square muna, then x, then c. Di ba ganyan naman ginagawa sa atin sa algebra? Okay? So that means itong 4x square ko na to, lipat ko siya sa other side. Okay? So lipat ko siya sa kabila. So I will get 0. Yung x square muna susulat ko. 54.3 x square. Then since yung 4x square lilipat ko sa right side, magiging negative sign yon. Negative 4x square. Ano susunod? Nasulat ko na yung mga x square ko followed by the x. Yung x ko negative 81.45x. Then yung c, yung number lang, that's positive 375. Okay? Anong gagawin mo? Yung x square, pagsamahin mo siya, 54.3 minus 4, edi 50.3 yan. 50.3 x square minus 8145x plus 35,4375. Wala nang chemistry dito algebra lang to. Okay. Ayan na. Ito na yung format ng equation natin. We already patterned it dito sa format. Ax square, 50.3x square, plus bx, negative 81.45x, plus c, 30.54375. Okay. So after nyan, alamin mo yung values ng a, b, and c. Okay. So ano yung value ng a? Yun yung coefficient ng x square. So a is 50.3. Ano yung value ng b? Yun yung coefficient ng x, that is negative 81.45. O yung mga negative sign, isasama mo yun ha. Huwag nyo kakalimutan. Okay. And then the value of c for this quadratic equation is 30.54375. Okay? So yan. So since alam mo na yung value ng a, b, and c, again, paano ko nakuha yon? Kapag a, yun yung coefficient ng x square. Yung b, yun yung coefficient ng x. Yung c, yun yung number lang. Okay? So since alam ko na yung values ng a, b, and c ko, ano na gagawin ko? I will plug these numbers into my quadratic equation. Ano ba yung quadratic equation? At, teka lang. Gumagalaw yung screen. Okay. So, ano yung quadratic equation? That is x equals negative b plus minus the square root of b square minus 4ac over 2a. Okay? So, yung values ng a, b, and c, ipa-plug in nyo dito and you will get two values. 2x values. Bakit sir dalawa yung x value na makukuha ko? Kasi ganito, tignan nyo, may plus minus. Ibig sabihin, yung isang x, positive yung sign neto. Yung isang x, negative yung sign neto. So yung plus minus, yun yung reason ba't dalawa yung roots. No? So sabi kasi sa algebra, kung ano yung highest degree, ganun karami yung solution, di ba? So kunwari, x cube yan. How many solutions are there? Tatlo yung solutions niya. Tatlo yung value ng x pag ganun. Kunwari, x square. O, ilang value ng x makukuha mo dapat? Dalawa. Kunwari, x raised to 5 yan. 5 yung value ng x. No? Diba? Algebra ginagawa natin. No? Amazing. Okay. So since this is quadratic equation, x square yan, we will get 2x values because of the positive negative symbol here sa quadratic equation. O ito, hindi ko na siya ipa-plug in ha. Kasi ang ginawa ko, doon sa worksheets na in-upload ko sa Canvas, doon ko pinakita yung pag-plug in ng x values. O you can format the problem na lang doon. Pakita ko sa inyo. Kasi ilang minutes na lang malapit na tayo matapos yung session. Again, hindi tayo katulad ng lab na ang daming time. So, parang nagmamadali talaga tayo every time na wala tayong magagawa. Okay. So, pakita ko lang yung tinutukoy ko dito sa worksheet. Kunwari, ito. Pinakita ko dito yung substitution ng A, B, and C sa quadratic equation. So, pwede nyo sundan na lang ito. Okay? Ayan na. So, pinag-in natin, finormat natin yung equation as x squared plus x, then coefficient. Okay? Then, alamin mo yung ABC. Then, ipa-plug in mo yon dito sa quadratic equation, quadratic formula. So, yung isang x, positive yung positive yung sign ng square root. Yung isang x, negative yung sign ng square root. Pa-plug in mo lang yan lahat. Carefully i-plug in para tama yung makuha mong x values. So, marami akong ganyang ginawa. Dalawa lang actually kasi yung sumunod na, tinamad na ako. Sabi ko dyan, use the quadratic equation. Hindi ko na ipapakita kasi nakakatamad na. Pero ito yung values, okay? Kasi hopefully by this time, alam nyo na mag-plug in. No? Kaya nyo yan. College na naman tayo. Okay? So, ganun lang. So, again, para mag-guide kayo, tignan nyo lang itong worksheet natin. Okay? So, let's solve for the values of x. No? Gagawin ko yung calculator shortcut. Kapag di pa alam, panoorin na lang yung video na nilink ko sa chat box natin. Okay, so type ko lang sa calcu. 53, negative 81, 45. Okay, tapos na. X1 is equal to 1.029. Di ba, bilis? X2 is equal to 0.5898. Di 590 na lang. Okay. So, and I have 2x values. No? Kasi dalawa yung roots ng ating equation. Daming numbers, no? Paka-zoom in na lang yung MS Teams nyo kapag ganyan. Okay. Ang susunod. Dalawa yung x values natin. Isa lang yung kailangan mo dyan. Kasi di naman pwede dalawa yung sagot mo dyan, no? Ano yan? The more answers, the better. Hindi. No, isang x value lang kukunin natin. Kahit dalawang x value yan, tatlong x value, 4, 5, isa lang pipiliin mo doon. Ito yung question. Paano mo pipiliin yung correct x value? Ngayon, so dalawa lang criteria dyan. Una, kapag negative yung x na lumabas, huwag mo gagamitin yon. Discard it. Okay? So, hindi mo pwede gamitin yung negative x. Kapag kunwari, negative yung lumabas dyan, huwag mo yung gagamitin. So, we only choose those roots with positive values. Sir, what if may imaginary yan? Huwag mo rin gagamitin yung may imaginary number, ha? Kapag may imaginary number na lumabas dyan, most likely, nagkamali ka dito somewhere. So, walang imaginary concentration, ha? Again, walang negative na x, wala ring imaginary na x. We only choose the real number, no? When I say real number, yun yung integer lang. I mean decimal din. Okay? So, ganun. So, yung walang imaginary numbers. So, yun. Yun yung first criteria for the value of x. Only yung positive real number lang. Kasi ang problema, tignan mo, yung dalawang x natin, parehas positive. Sino gagamitin ko dyan, sir? Doon tayo sa second criteria. So, for the second criteria, you always choose the x that is less than the initial concentration. Okay. So, pipiliin mo yung x that is less than your I. Bakit? Kasi kapag yung x mo mas malaki sa I, kunwari, yung 1, 0.75 minus 1, sige. Negative 0.25 yon. May negative na concentration ba? Wala. No? Ay, may utang pa. No? Walang ganun. So again, ang pipiliin mo ay yung x value that is less than your I. Okay? Less than the initial concentration. Especially kapag isusubtract mo yon. Okay, so again, kapag pinag-subtract mo yan, tapos negative yung lumabas doon, mali yung x value mo. Okay? So you choose the x that is that is lower than your initial concentration. Okay? So ganun lang ha. Especially kapag isusubtract mo siya. So yan. So that means among the two choices that we have, x2 will be chosen. So x na si x1. Kasi bakit? Bakit x na yan? 1.029 yan eh. Okay. Lagpas yan sa 0.75. So, di ko gagamitin yung x1. Yung x2 gagamitin ko yung 0.59. So, I will plug in x equals 0.59 dito sa e. Okay? So, ganun yung pagpili ha. So, ano yun? 0.59. So, that means at equilibrium, H2 concentration is, okay, so at equilibrium, so ano yung H2 concentration natin? That's 0.75 minus 0.59 equal yun sa, pipindutin ko lang. Equal yan sa 0.16 molar. So yun yung concentration ng H2 at equilibrium. How about I2? Ganun din. Kasi same lang naman sila ng expression. So that will be 0.16 molar then. How about HI? So that is twice the value of X. So that will be 2 times 0.59. The answer is 1.18 molar. Okay. So that's how we solve for this problem. Okay. So ganun lang. Ang daming solution na ganun talaga. So again, I will suggest you to try to re-answer this after the class na lang. Siguro mga weekends. Pag-aaralin nyo to. Bigyan nyo to ng more time. And paki-practice yung algebra ha. Kasi pansin ko, sa senior high tinuturo ko to dati. No? Ang napapansin ko, yung chemistry okay lang. Ano ba yung chemistry dito? Yung I stable pati yung K lang. The rest is algebra. Doon sila nadadali. Tama yung K nila, tama yung I's nila. Pero pagdating sa sa algebra, doon nagkakamali. So you have to be careful then, okay? So paki-recall yung basic operations. For example, square of binomial, no? Square of trinomials, no? Just in case lang na magamit. Pero I suggest you na mag-practice na lang kayo sa FOIL method. The more na mabilis kayo mag-FOIL method, mas mabilis nyo matatapos tong problem na to. Especially if your calculator can do the solving for x. Okay? Pag kaya ng calculator mo isolve yung value ng x, mas madali. Okay? So yun lang. Yun lang suggestion ko. Okay, so yun. Again, pag dalawa yung x value mo, 3 or 4, so on, so forth, gagawin mo is, piliin mo yung positive x value and kung parehas yung positive, piliin mo yung x value less than the initial concentration. One way to check if tama yung sagot natin, i-plug in mo yung equilibrium concentration sa K expression. Dapat ang makuha mo na value ay 54.3. Or pwede rin may subtle change sa decimal kasi nag-round off tayo. Pero as much as possible, near this value, yung makuha mo sa K kapag plinag in mo yung equilibrium concentrations dito sa K. Okay? So, ganun lang. Ayan yung two examples natin. So, more examples are already posted sa ating worksheet. No? Yan, practice na lang kayo. Ito, yan? Kamali lang ako dyan. Sa laboratory. Ayan. So, ano na lang yan. Never mind na lang. Okay. So, let's proceed with the last part of chapter 3, factors that affect chemical equilibrium. Okay, so let's imagine equilibrium as a seesaw. Okay, a seesaw that is balanced, no? May reactant ka, may product ka. Imagine mo, balance yung seesaw na yan. Okay, so may weight ka or may mass ka dito sa reactant, sa product meron din. So balanced yan. What will happen if you modify something sa seesaw mo? Masisira ba yung balance? Yes, no? O kunwari yung reactants, lagyan ko ng isang pebble, hindi na pantay yan. Okay? Kunwari, baguhin ko yung hangin sa paligid. Pwedeng ma-disrupt yung balance. Okay? So that means equilibrium are delicate. Equilibrium systems are delicate systems. No? Ibig sabihin, they are prone to sudden changes sa paligid. Okay, so yung balance na yon that could easily be disrupted. However, since we know that lahat naman ng system, pupunta rin siya sa equilibrium, pupunta din siya sa balance, no? Ito try niya i-establish yung equilibrium after siyang magulo, no? After siya guluhin. Okay, so yung concept na yon that was laid to us by Le Chatelier in his principle, Le Chatelier principle. Ito, iba-iba basa dito pero mahalaga, alam natin yung spelling. Okay, so yung iba sabi dyan, Le Chatelier, tulad ko, yung iba, Le Chatler, di ba? Yung iba naman, Le Chatelier, no? French, no? French kasi siya. So, yan. So, ayun, babasahin ko yun, Le Chatelier principle, ha? Ganyan yung spelling niya talaga. Okay. So anyway, so sabi ko kanina, yung balance na to, delicate yan, and that can be re-established. No, yun yung concept ni Le Chatelier sa kanyang Le Chatelier principle. Basahin natin ang kanyang sinabi. If an external stress is applied to a system at equilibrium, the system adjusts in such way that the stress is partially offset as the system reaches a new equilibrium position. In Tagalog, sabi niya, kapag yung system daw ginulo mo, it will try to re-establish the balance. Okay. Question, paano niya i-re-establish yung balance? It will shift the equilibrium. Okay? It will shift the equilibrium position. So that means pwedeng to the right or to the left yung puntahan ng system in order to achieve the balance again. Okay? Ayan, babalik na naman yung QC and KC, no? So, ganun. Anyway, walang calculation dito. Concept lang. So, again, ulitin natin yung Le Chatelier principle. Sabi dito, kapag yung balance ginulo, the system will try to achieve the balance again. It will re-establish the equilibrium. No? How? By shifting the position of your system. Okay? So, by shifting the reaction. Pwedeng mag-shift siya to the left or shift to the right in order to achieve balance. Okay. According to Le Chatelier, may apat na concerns about equilibrium. May apat na factor that could affect the equilibrium. No? Number one, change in concentration, change in pressure and volume, change in temperature, and the effect of catalyst. So, isa-isahin natin to. Changes in concentrations. Sabi dyan, increasing the concentration of product shift the equilibrium to the left. Decreasing the concentration of the products shift the equilibrium to the right. Pag unang binasa nyo yan, ang sasabihin nyo, ano daw. No? Kasi ganun din yung ko nun nung na-discuss sa amin to. Yun yung first reaction ko nung college ako. Okay. So, para mas maging clear to, gawa tayo ng analogies para mas makita natin yung shift to the left or shift to the right. No? So, imagine your equilibrium system, yung reactant and product as two buckets of water na connected sa ilalim. So, anong mangyayari kapag connected yung container na yan? Pantay lang yung water level, di ba? So, always pantay yung water level kapag connected sila sa ilalim. Okay? And that is governed by physics, no? Yung atmospheric pressure, dapat magpapantay lang sila. Yun yung equilibrium, yun yung balance. Okay, so ganito. Imagine natin yung concentration ng species as water level. Okay? Kunwari, ito yung balance. Yan, pantay sila. Basahin natin yung first sentence. Increasing the concentration of product shifts the equilibrium to the left. Interpret natin yan sa ating water bucket. So yung nasa left, yun yung reactant, yung nasa right, yun yung products. Sabi dyan, if you increase the concentration of products, mag-shift yung reaction to the left. Apply natin yung sa analogy. So suppose dadagdagan mo to ng tubig. So dadagdagan ko yan ng water. So tataas yung water level. Anong mangyayari? Since gusto nga ng system natin ay i-balance yung water level, it will push the water to the left. Okay? So the atmospheric pressure will push the water to the left in order para maging balance na uli sila. Okay? So again, increasing the amounts of products will push the reaction to the left. Okay? Imagine niyo na lang yung dalawang bucket ng tubig, lagyan mo ng additional water yung right side, yung excess water dito, mapupush yun papunta sa left in order to achieve balance. Okay? So yun yung interpretation natin sa first sentence using our analogy. Increasing the concentration of product shifts the equilibrium to the left. Pag dinagdagan mo to, it will shift the equilibrium papunta sa left in order to make everything balanced again. Okay? Second sentence, clear ko lang yung akin sinulat. Second sentence, decreasing the concentration of the products will shift the equilibrium to the right. Imagine nyo, water bucket ulit. We have the water bucket. Sabi dyan, yung product binawasan mo compared to your reactant. So yan, binawasan mo yung product, yung reactant hindi. What will happen? Yung water sa left, mapupush yon towards the right so that magbabalance sila over time. Para magbalance sila. Okay? So yun yung yun yung logic dito sa second sentence, that when you decrease the concentration of product, it will shift the reaction to the right. Imagine a water bucket connected, no? Imagine two water buckets connected. Pag binawasan mo yung nasa right, yung water, automatic magfo-flow yan to the right, no? In order to establish the equilibrium again. Okay? Hopefully, nakakatulong tong drawing na to, no? Ewan ko, dito ko kasi na-gets to eh. Kasi kapag kinabisado ko lang yan, nalilito ako eh. Okay? Until now, nagbabakit-bakit analogy ako. Okay. Yan. So, di ba ang focus natin puro products, di ba? When you increase the concentration of product, it will push the equilibrium to the left. If you decrease the concentration of product, it will push the equilibrium to the right, no? What if yung naman, yung sa reactant? Tignan natin yung point of view ng reactant. Suppose ito yung ating balance. What if dagdagan ko yung reactant? What will happen? If I increase my reactants, the system will shift to the right. Okay? So increasing the concentration of the reactants will push the equilibrium to the right. Okay? It will shift the equilibrium to the right. No? Kasi mas mataas yung water level dito. So that means para mag-balance sila, yung ibang tubig magta-travel papunta sa right side, no? To achieve the balance again. Okay? Ayun lang yung logic dyan. What if yung reactant naman ay binawasan mo? Hulaan yung mangyayari. What if binawasan mo yung reactant? Kunwari, ito lang yung reactant, binawasan ko na. What will happen to the equilibrium system? The equilibrium system will be shifted to the left na. So, masishift siya to the left when you decrease the concentration of your reactants. No? So use the water bucket analogy para mas para mas ma-visualize nyo kung saan pupunta yung reaction. Okay? So yan. So that's for the change in concentrations. So our chemical equilibrium can shift to the left to the right depending on the changes in the amounts of your reactants and products. Use the water bucket analogy, no? So kung kaya nyo siya gawin, i-demonstrate talaga at home, no? May dalawa kayong baso, pagdugtungin nyo ng straw sa ilalim, yan, mas madali, no? However, I do not have that, I don't have that example sa ngayon. Wala akong straw dito kasi bawal na. Okay, so next one. Changes in pressure and volume. Okay, so when you change the pressure, may effect yun sa equilibrium system mo. Okay, basahin natin yung sentence. Increase in pressure, ibig sabihin yan, will favor the net reaction that decreases the total number of moles of gas. So, ibig sabihin nun, when you increase pressure, it will favor the side of the reaction with less mole of gas. And so, it will favor the side of the reaction with less moles of gas. Okay? But if you decrease the pressure, it will favor the side of the reaction with more moles of gas. Okay. So again, increased pressure, it will favor the side of the reaction with less mole of gas. Decreasing the pressure, it will favor the side of the reaction with more moles of gases. No? So ano yan, sir? Shift to the left, shift to the right. Depende. Hanapin nyo kung nasan yung less mole of gas, hanapin nyo kung nasan yung more moles of gas, no? Para malaman nyo where the reaction is shifting. Okay? So may example tayo about this mamaya. Okay? Para mas makita nyo. So for now, ganito lang muna kabisaduhin natin. Increased pressure, it will favor the side of the reaction with less mole of gas. If you decrease pressure, it will favor the side of the reaction that has more moles of gases. Next one, changes in temperature. So our reaction could either be endothermic or exothermic reaction. Okay, a temperature increases. A temperature increase favors an endothermic reaction and a temperature decrease favors an exothermic reaction. Ano daw yun? Ganito yan. Bago tayo pumunta sa mismong explanation, ano muna yung endothermic pati exothermic? So that is the sign for your enthalpy change, your delta H, no? That is energy. Kapag endothermic yan, your delta H is positive. So ano meaning nun? The reaction will absorb energy para mag-proceed siya. Pag exothermic naman, delta H is negative. So that means magre-release yan ng energy. Okay. So paano ko po mabivisualize itong changes in temperature? Okay. So you can use the water bucket analysis ulit. The water bucket analogy natin. So balik tayo sa water bucket. Suppose we have a reaction that is endothermic. That means delta H is positive. Okay, so we have an endothermic reaction, delta H is positive. So you can imagine heat, since endothermic to, you can imagine heat as your reactant. Okay? So imagine nyo yung heat reactant siya. Okay? So ganun lang. Teka lang, ayan. So imagine your heat as a reactant if endothermic reaction yon. What will happen if you increase the temperature? Tataas yung heat, no? Tataas yung heat energy. So imagine mo madadagdagan yung amounts ng reactant mo. So in order to achieve the equilibrium, if you increase the heat, and that's an endothermic reaction, it will push the system to the right. Okay? So again, endothermic reaction, pag in-increase mo yung temperature, the system will be pushed to the right. Okay? Kasi imagine mo yung heat mo, reactant yan. By increasing the temperature, you increase the amount of heat. So, dumadami yung reactants. So, in order to achieve balance, mapupush yun to the right. So, that's for endothermic reaction. What if you decrease the heat? No? What if you decrease the heat? Oh, dito naman tayo. We still have the same equilibrium, endothermic pa rin. So, yung heat, reactant yan kapag endothermic. Okay. So, what if binaba mo yung temperature? So, imagine mo, yung reactant side mo, mababa. Pag ganun. Kasi binabaan mo yung temperature. So, what will happen to the equilibrium? It will be shifted to the left. Okay? So, ganun. In order to achieve the balance again. So, ito yung logic natin kapag endothermic reaction. Pag endothermic reaction, imagine your heat as the reactant. Increasing the temperature means increased heat. Okay? So, if you increase the temperature, you increase the heat, then it will push the reaction to the right. Kapag binabaan mo yung heat, binabaan mo yung temperature, it will decrease the heat. So, ibig sabihin, onti yung reactant. It will, in order to achieve the balance again, it will push the reaction to the left now. Itong pagbaba ng temperature. Okay? So, yan. Pwede natin magamit yung water bucket analysis natin. Analogy. Ba analysis sinasabi ko. Okay, so ganun ha. So again, increasing the temperature for endothermic will push the reaction to the right. Decreasing the temperature for endothermic reaction will push the reaction to the left. Oh, how about exothermic? Exothermic. So we can also use the same analogy for exothermic reaction. So, pag exothermic reaction naman, 'di ba sa endo reactant yung heat, sa exothermic product yung heat, no? So nilalabas siya ng equilibrium system natin. That is exothermic or delta H is negative, no? Exo, delta H negative. Hindi yung K-pop group, ha? Okay. So what will happen if you increase the temperature or you decrease the temperature for exothermic reactions? Imagine nyo, if you increase the temperature, dadami yung product mo. So ano mangyari? To achieve the balance, the water will be pushed to the left. Ibig sabihin, the equilibrium will be shifted to the left. Kasi mas marami yung products mo kaysa sa reactant when you increase the temperature. Again, exothermic to ha, hindi to endothermic. So increasing the temperature, nataas yung heat. Ibig sabihin nun, mas maraming products tayo. It will push the system to the left. Okay? How about when we decrease temperature? Pag binaba natin yung temperature o onti yung ating product side. Pag umonti yung product side, in order to achieve balance, the system will push or will be shifted to the right na. Okay, the water will be pushed to the right in order to achieve the balance na. So yun na. So ito ay counterpart ng endothermic na. So baliktad sila ng case. Sa endothermic, increase temperature to the right, decrease temperature to the left. Pag exothermic, increase temperature to the left, decrease temperature to the right. Okay? So ganun yung So ganun. Pwede nyo naman kabisaduhin na lang yun or just use the water bucket analogy. No? So yan. And last one, we have the effect of catalyst. So ano ba yung epekto talaga ng catalyst? No? So the effect of catalyst is that they lower the activation energy. If you could still recall your Gen Chem 2, what is an activation energy? That is the energy barrier of the reactions. No? Okay. So suppose this is the energy of your reactant, this is the energy of your product. May malaking hump yan in between. We call that the activation energy. So, anong ginagawa ng catalyst? Catalyst lower this activation energy. Pinapababa niya yan so that the reaction will happen faster. Okay? So the reaction will occur at much faster phase na. Okay? So ganun. Daming letter F. Okay, so ganun para mas mabilis yung reaction. So it will change the uh, rate of reaction, yung forward and reverse reaction, bibilis sila. However, since equally sila na increase, no? They are increase at the same extent, hindi mababago yung equilibrium system natin. Okay? So again, yung catalyst, they lower the activation energy by speeding up both forward and reverse reaction. In both forward and reverse reaction, pinapabilis niya. So since nagka-cancel out yung extent ng increase sa dalawang reaction, hindi affected yung equilibrium system. Okay? So ganun. So that means pag may catalyst, lalagay nyo no effect. Okay? So wala siyang effect sa equilibrium constant natin. So it will not shift the reaction to the left to the right. No? And let's try to answer some problems here. Ito dalawa. Consider the following. We have N2F4 in equilibrium with 2NF2, both in gases. Delta H is 38.5 kilojoules. Number 1, reacting mixture is heated at a constant volume. Ayan, heated. Ibig sabihin, tumaas yung heat. Tumaas yung temperature. So kapag tumaas yung temperature, ano gagawin natin? Check mo muna kung endo yan or exo. Look at the delta H. Ano sign niya? That's positive. Okay, so positive yung delta H, so that is endothermic. So ibig sabihin nun, you have to imagine that heat is a reactant. Okay. So if heat is a reactant, tas tinaasan mo yung temperature, ibig sabihin nun, dadami yung reactants mo. Okay, so dadami tong reactant mo. In order to achieve equilibrium, the system will shift to the right, no? Kasi marami kang reactants dahil in-increase mo yung heat, no? So, using the water bucket analogy, since mas marami sa left, yung ibang water mapupush to the right. So, the equilibrium will be shifted to the right. Okay? For endothermic reaction, when you increase the temperature. Letter B, some N2F2 gas is removed at constant temperature. Okay, so some N2F2 gas is removed. So, ibig sabihin, binawasan mo yung iyong reactant. So, this is change in concentration. If you decrease your reactants, what will happen to the equilibrium? Decrease reactant yan. The equilibrium will be shifted to the left. Okay? So the equilibrium will be shifted to the left when you decrease your reactants. Imagine the water bucket again. Kapag mas onti yung tubig sa left kaysa sa right, yung tubig magra-rush papunta sa left. So in equilibrium, ibig sabihin nun, it will be shifted to the left. Next one, pressure is decreased at a constant temperature. Ito yung sinabi ko kanina. Yung about sa pressure. Di ba sabi natin, increased pressure means it will favor less moles of gas. Decrease in pressure, it will favor more moles of gas. Okay, so increased pressure favored ang less mole, decrease in pressure favored ang more moles. Ganito gagawin nyo. Look at the equation. Bilangin mo kung ilang moles of gas you have for the reactant and for the product. For the reactant side, we have 1 mole of gas. For the product side, we have 2 moles of gas. Basahin uli yung question. Pressure is decreased. Basahin natin to. If you decrease pressure, it will favor more moles of the gases. Asan yung more mole ng gas? Nasa product side. So that means it will shift the reaction to the product side or to the right. Okay? Again, para sa mga pasabi daw? Ganito. Kapag binaba mo yung pressure, mas gusto niya yung mas maraming moles. So, since yung mas maraming mole natin nasa right side, so ibig sabihin nun, it will shift the reaction to the right. Okay? So, ganun lang. What if i-increase mo yung pressure? Mas gugustuhin niya yung less mole ng gas. Yun yung nasa left. So, it will shift the reaction to the left. Nanto question dyan. Always po ba to the right kapag pressure decreased? Hindi. Okay, hindi siya always ganyan. Bibilangin mo kung ilang moles ng gases meron ka. Kasi depending on the mole of the gases, yung side na yun yung pwede niya i-favor. No? Okay? So, kunwari, ito yung 2 mole, ito yung 1 mole. So, kapag dinecrease mo yung pressure, i-favor niya yung reactant. Okay? Just in case, kunwari, baliktad to. No? So, ganun, ha? So, yun. So, depende pa rin yun sa mole of gas. Ito isang question ko dati sa student ko. Sabi niya, Sir, what if equal yung moles mo? Okay? So, what if equal yung mole mo? Kunwari, ito, 2 moles. Ito, 2 moles din. Will there be an effect sa pressure? Ang sagot ay wala. No? Kapag equal yung moles ng gases, wala nang effect yon. Okay? So, balanced na yon already. Pero kapag magkaiba yung moles nila, then dun pwede mag-shift na to the left, to the right. Okay, so ganun ha. So tignan nyo muna yung moles ng gas. Kapag equal yan, walang magbabago. Pero kapag unbalanced yan, hindi sila parehas, then dun nagkakaroon ng shifting. Last one, catalyst is added. No? When catalyst is added, ang sabi natin, no shift. No? Walang pagbabago. No effect. No effect. Okay? Kasi again, catalysts speed up the rate of reaction, but they do not change the equilibrium. Pinapabilis nila yung reaction pero hindi nila binabago ang equilibrium. Okay. Let's work with last item here. Ayan. Consider this equation. Delta H is, okay, may mali sa delta H. That is actually 284 kilojoules positive. Positive pa rin yung kilojoules natin dito. So, ayan. From this equation, answer the following. Number 1, increasing the pressure of the system. Again, bilangin mo yung moles. On the left side, we have 3 moles. On the right side, we have 2 moles. No? So when we increase the pressure, it will favor the side of the reaction with less mole of gas. In our case, yung product side. So when we increase the pressure, this equilibrium will be shifted to the right. Okay? Kasi dun yung mas onti yung moles ng gas kaysa sa left side. No? Adding oxygen to the system. Imagine water bucket again. Dinadagdagan natin reactant side, so it will push the equilibrium to the right. No? So sana ma-develop nyo yung kapag nakikita nyo yung equation ng equilibrium, may nakikita na kayong water bucket agad. Kasi ganun yung nai-imagine ko agad. May water bucket dito. Pag sinabing add oxygen, dadagdagan mo ng tubig yung nasa left side. So to achieve balance, yung ibang tubig pupunta sa right side. So shift to the right yan. Okay? Sana ma-develop nyo yung ganung analogy. Next one, decreasing the temperature. Okay, so itong decreasing the temperature, depende to kung endothermic or exothermic to. In our case, endothermic uli ito. So that means the reaction is, yung heat ay nasa left kapag endothermic. O, imagine mo uli, water bucket yan. So kapag dinecrease mo yung temperature, mas onti yung nasa left side mo. So that means the equilibrium will be shifted to the left. Okay? So kasi mas onti yung nasa left mo kaysa sa nasa right mo. No? So mangyayari, in order to balance them out, some of the chemicals on the right side will be shifted to the left. Okay, bakit nga ba bumaba yung nasa left? Kasi binabaan mo yung temperature. No? Imagine your heat as concentration. No? Para mas madali siya ma-imagine. Lastly, adding a catalyst. Sana ito na lang yung nasa quiz, no? Sagot dyan, no effect. So, walang effect yan. Because, again, they speed up the reaction, but they do not change the equilibrium system. Ayun lang. Okay, so that will be the last one. Ito, additional material na lang. Now, this is an application of the Le Chatelier principle, the common ion effect. This will be discussed in the laboratory. Okay? Discuss to sa chapter 4 laboratory. Okay? Pero mabigyan ko na kayo ng insight kasi kukwento niya yun dun eh. So, what is a common ion effect? So, a common ion effect is a phenomena wherein your solution contains common ions to your salt. Ibig sabihin yung solution mo may kaparehas na ion sa salt mo. Suppose we have barium chloride. Okay? If we write the equilibrium expression for barium chloride, that will be barium 2 plus and 2Cl minus, di ba? What if maglagay ako ng NaCl sa akin solution? What if maglagay ako ng NaCl? Ano yung common ions ko dyan? Yung Cl. Okay? So ano mangyayari when I add Cl sa aking system? Imagine nyo yung water bucket. Pag itong solution ko, nilagyan ko ng Cl ions, common ions, ibig sabihin nun, dadami yung products kaysa sa reactants. No? So imagine the water bucket analysis natin. So kapag mas marami yung nasa product, in-increase mo yung concentration ng product, it will push the reaction to the left. So that means your salt will be less soluble. Okay? Mamumuo yung salt mo na yan. Meaning, saturated na siya. Okay? So, ganun. Dinamihan mo kasi yung common ions. So, sir, ano yung common ions? Yun yung ions na parehas sa salt and sa solution mo. Okay? So, kunwari, itong barium chloride in NaCl solution, ano yung common ion nila? Yung Cl. Kasi parehas silang Cl. So, yan. Ano mangyayari kapag may common ion effect? Your salt will be less soluble. Ibig sabihin, mas mamumuo siya. Okay? So, ganito yung ginagawa sa paggawa ng crystals. No? So, maglalagay ka ng common ions in order for your crystals to precipitate out or to grow. Bigay pa ako isa pang example. Ito, isa pang example. Kunwari, KCl. Itong nasa text sa baba. Suppose we have KCl. Ano yung equilibrium niyan? Magpuproduce yan ng K plus and Cl minus. Suppose maglagay ako ng KNO3. Ano yung common ion nila? Yung K plus. Yung K plus sa KCl and yung K sa KNO3. Yan yung common ion. So, ano effect nun? Ano yung common ion effect? It will push the reaction to the left. So, that means KCl will be less soluble because of the common ion. Yun yung effect niya. So, yan ang application ng Le Chatelier. Dinamihan mo yung products mo, so it will push the system to the left. That means your salt will be less soluble. Okay? So, yung common ion effect, i-discuss yan sa lecture, sa laboratory, chapter 4. Okay, so hopefully tapos na kayo sa gravimetry kasi yun yung kasunod. Bigyan ko na kayo ng intro for the next week discussion. Ito, intro lang to. Di ba may common ion effect tayo? May counterpart yan. Tawag doon ay diverse ion effect. Ito yung video sa YouTube channel ko na until now, dami nanonood. No? Kasi wala masyadong discussion about diverse ion effect. No? So far, 3 lang ata kami na may ganitong explanation doon. Kaya until now, nakikita ko, may nagko-comment pa rin doon. Mga Indian pa, no? Nakakatuwa, no? Kasi usually Indian nagtuturo sa atin, di ba? Sa YouTube. Okay, so yan. Okay, so kwentuhan ko na yung discuss natin next meeting, diverse ion effect. So what is a diverse ion effect? No? So from the word itself, diverse ion, ibig sabihin, you add ions to your solution that is different from your salt. Okay, suppose you have AgCl. So magdi-dissociate yan into Ag plus and Cl minus. What will happen if you add potassium nitrate? May common ion ba dyan? Wala. Kasi walang potassium sa Ag, walang potassium, walang potassium din sa Cl. Wala ring nitrate sa Ag, wala ding nitrate sa Cl. So, ano effect niyan? Kung iisipin mo yung Le Chatelier principle, di ba? Parang wala naman siyang effect. Okay, so feeling ko wala yung effect na. Pero to be honest with you, may effect yan, no? Okay. So kasi, tingnan mo, wala namang KNO3 sa equation natin. So wala tayong common ion, di ba? So ibig sabihin nun, dapat hindi magalaw yung equilibrium. But the reality is may effect yan. Okay? So that will be the premise of our discussion next week about sa diverse ion effect. Be ready with logarithmic equations. Okay? Nagagamit tayo ng logarithm kasi next week. Okay? So, yan lang. Again, algebra and logarithms next week. Okay? So, yan. So, good luck. And for now, we're done with the chapter 3 already. So, na-discuss na natin lahat ng kailangan i-discuss for chapter 3. Hopefully, makapagsagot kayo ng quiz 2. Quiz 3 agad. So, just go to your canvas. Open na yung quiz 3 part 1. Yung quiz 3 part 1, ang coverage nun ay yung diniscuss natin last week. So, hopefully na-review na siya. Pag hindi pa, again, punta uli kayo sa announcement. Andun yung worksheets. Okay? For part 2, that will open starting March 3 to March 6. So, that's Wednesday until Saturday next week. Okay? Pero may regular class tayo nun, ha? So, ito yung equilibrium calculations. Okay? So, pakiaral na rin sila. Kailangan mo gumamit ng quadratic equations. Share ko pala, no? What if, kunwari, yung calculator nyo hindi kaya mag-quadratic equation? Okay. Ganito, punta kayo sa Symbol Lab. Okay, so symbollab.com. May app to kaso may bayad eh. Although may free version. Mali yung spelling ko. Symbol Lab. So itong Symbol Lab, I use this kapag ako ay tinatamad mag-quadratic equation. Pero alam ko naman kasi kung paano mag-quadratic equation. So okay lang sa akin gumamit nito. So kayo, kung hihimay-himayin nyo pa yung quadratic equation, i-work out nyo muna yan, no? Okay. So yan, kunwari, I have the K expression, 54.2 equals, hopefully naalala ko pa yung pinagsusulat ko kanina doon. 54.2 equals, okay. Ano ba yung nasa numerator nun? 2x square yun, di ba? 2x, then close parenthesis, square. Then sa denominator, you have 0.75 minus x. Then another 0.75 minus x. Click mo lang yung enter. Then lalabas na yung values ng x mo. And so you have 1.09, 1.029, and 0.589. Okay? Anyway, gagamitin nyo lang to kapag yung calculator nyo hindi kaya. Ayan. Mas mas God tier kapag alam nyo yung calcul nyo. mas mas maganda kapag alam nyo yung sa calculator gawin. Okay. So, yun lang. So, that means, wag kayo depende masyado dito pero shinare ko na kung paano. Okay. Para kapag nagre-review kayo, mabilis, no? Pero hopefully kapag quiz, no? Kapag wala na talaga kayong option, sige, try nyo yan. Pero it will still be better if you can do your calculator techniques. No? Kasi pagdating ng exams, let's say board exam, calculator lang yung meron. Okay. So, yan. So, yan. So, you have all the options for learning. Hopefully, you maximize them. Okay. So, yan. I'll see you again next week. Chapter 4 discussion tayo. That will be the last discussion prior to your midterm exam. Hopefully, we can accomplish that agad-agad, no? Para you have a week for review na lang. Okay. So, I will upload more materials a week before the exam, no? Para ready na talaga kayo for the midterms. So, good luck and I'll see you again next week. So, goodbye and enjoy your uh, enjoy your life. No? So, a copy of the class recording will be uploaded on YouTube tonight. No? So, yan. So, I'll see you again. Bye-bye po.
Thank you po, sir.